What's going on, guys? Mr. Jones coming at you once again. Going to show you guys Ready, Set, Go 1.8. That's going to be the assignment for today. So I'm just going to go over each section. Please write stuff down. Okay, please take notes. This is going to be a lot of stuff that's going to be on the test. Okay, so notice on the left-hand side you see the problems. On the right-hand side, I'm going to solve them for you, or talk about them at least. All right, here we go. So the very first section says, find the common ratio for each geometric sequence. So first of all, whenever we see the words common ratio, we should already think of geometric sequences. But then it's nice and it tells us that they are geometric sequences. So what is the common ratio, right? So you have to know that the common ratio, that's just whatever the heck you're multiplying by every time, right? Multiplying by. So if you don't have this in your notes, then make sure you get it, because that's what common ratio means. So if you didn't know what it means, it's really hard for you to answer the questions. All right, whenever you see numbers written like this, those are always the y values. So whenever me and Mr. Norman make tables, we always write them up and down like this, okay? And we always like to put a 0 in the front, because the 0 we need for our equations a lot of times, right? Okay, so, but whenever you see numbers written from left to right like this, you always are starting off with the first term. So if you didn't know that, that's very important. It's not that important for these problems, because you don't need to know what the y-intercept is. But it is still important, and you need to know that. Okay, so here we go. 2, 4, 8, 16. That's my first term through my fourth term. And all it's asking for is, what is your common ratio? So it's just saying, what the heck am I multiplying by every single time? And hopefully if you guys look at this, you could easily tell that the answer is 2. But let's say you couldn't tell, because some of these you're not going to be able to tell as easily. Okay, some of these you're not going to be able to tell as easily. The first thing you always want to do, by the way, whenever you look at these is ask yourself, are you multiplying or are you dividing? If the numbers are getting bigger, you're obviously multiplying. If the numbers are getting smaller, you're dividing. So just keep that in mind, okay? But if we didn't know we were multiplying by 2, how could we test it? Okay, I'm sure you've seen this before. I'm going to show you one more time because it's pretty good. You're just going to divide backwards, and it's going to tell you automatically what the answer is. So 16 divided by 8. If you put that in your calculator, or you just know it, the answer is 2. And you could do it again, and you should do it more than once just to make sure it actually is the same number. 8 divided by 4 indeed is 2. So make sure it's the same number. If it's the same number, that's how you even know it's geometric to begin with, and now you've just found your common ratio. So 2 would be the answer. That's what we're multiplying by every time. And this up here was just us proving that it was 2, okay, by actually dividing backwards. All right, the next section, 5 through 8, I believe, is asking the same thing. It's recursive and explicit equations. Fill in the blanks for each table, then write the recursive and explicit equation. Okay, it doesn't say if these are arithmetic or geometric this time, so keep in mind you have to figure out what it is based on if it's adding or subtracting, which would be arithmetic, or multiplying and dividing, which would be geometric. Okay, so you just have to basically look at the table and write the equation. So I'm not super nice, so I'm just going to go ahead and give you an example of one that it's not even up here. It's just a random one, but it's going to be the same concept as what you're seeing. So I'm going to put 1, 2, 3, 4, and I'm going to do, let's do 3, 6, 12. Let's actually change that. Let's actually change that. I don't want to do geometric after all. Let's just do an arithmetic one because it's easier for me to make up one in my head. So let's do 6, 10, 14, and 18. All right, so there's my sequence. We'll pretend that it's one of the problems over there on the left. And here's what we would have to do. You'd first say, do I know if this is arithmetic or geometric? Am I adding something or multiplying something? So you can either figure it out by working backwards, or you can figure it out because you just can tell that 6 plus 4 is 10 plus 4 is 14. If it was multiplying, you'd say 6 times what is 10? That's kind of weird. And the numbers are not growing fast enough. So we know it's arithmetic. And I just told you that we're adding by 4 every single time. So that's cool. And then it says fill in the blanks. Okay, so you're going to have, you already have a 4. I did that on accident. So we'll go ahead and put the 5 here. And we're going to fill in the blank in a minute. Okay. The first thing I like to do is just be like, all right, cool, let's just get this recursive equation out of the way. Okay, because we're already thinking add 4, add 4, add 4. So we're thinking of the recursive equation. We just don't know it. So to find the term we're looking for, which in this case is the 5th term, okay, I take the previous term, which in this case would be up here, the one right above it, right? And what am I going to do to get it? I'm going to add 4. So once I do add 4, 18 plus 4 is 22. And so that's how we got 22. We're just adding 4. This is my recursive equation. This is it. That's all we have to do. The only thing different is you just really need to define a point. So usually you just put in here, hey, my first term, that's not what I wanted. My first term equals 6. This is just called defining a point. Okay, so make sure you define a point. I just chose this point. If x is 1, y is 6. So that's exactly what this is saying. So that's your whole recursive equation, everything that I've written down there so far. All right, explicit equation is the one that looks like this. If it's arithmetic, it's y equals mx plus b. Okay, remember, this is my slope. This is my y-intercept. You already should have that in your notes, so I'm not going to write it down. But my slope is my common difference. Okay, so this 4 is there. This b value right here, that's going to be your y-intercept, which is your 0th term. So we don't know what it is because we don't have it, but whatever number goes there is going to be my b value in my equation. So what number does go there? Well, I have to work backwards. So if I'm adding 4 every time, in my sequence from 6 to 10 to 14 to 18, I'm adding 4. To go backward, you subtract 4. And 6 minus 4 is 2. And you can verify 2 plus 4 is 6 plus 4 is 10. So you know that you have the sequence right. So your y-intercept, or your 0th term, is 2. And now you have all the information you need to create this equation in the form y equals mx plus b. Y still stays there and x still stays. We need to put our value for m in, which we already said was 4, right? And see, that went right there, bam. And we know what our y-intercept is and our b value, and I'll make that red. I don't even know why I choose the colors I do sometimes, but anyways, the b value, we're pointing to it right here, is 2. And so y equals 4x plus 2 is your answer. Okay, so there's an example of that. All right, guys, this last section, the go section, is 9 through 12. I went ahead and just put a couple of them on the right-hand side so I can draw on it. But this one wants to write each equation of the line in y equals mx plus b form, so give the normal explicit form, and then name the value of m and b. So say what the coordinates of them are, not the coordinates, but m will be what is the common difference and what is the slope, and b is what are the coordinates of the y-intercept. Okay, so recall that m is slope and b is the y-intercept. Well, that was convenient since we just talked about that, right? All right, here we go. Let's make this as quick as possible. The first thing we always want to notice is what I like to do is realize if the slope is positive or negative right off the bat. You should be able to look at the line and know if it's positive or negative. If you haven't heard this yet, if Mr. Norman didn't teach this to you, I'm going to show you my little trick. And it's my friend Tom. Tom has a disease. He only could walk to the right. That's his disease. Here's Tom. He's a good-looking guy. Let's give him a backwards hat here. You know, he's always got a little smile, though. All right, there's Tom. He only can walk to the right, so whenever you put him on a line, he only could walk to the right, which is this direction. So if Tom is walking to the right, is he walking uphill or downhill? Uphill is a positive slope, okay? And downhill is a negative slope. Okay, so that's the easiest way to know which is which. So this equation, we automatically, I'm just going to put right here for my m, we know what's going to be positive, so that's going to help me so I don't make that mistake. And over here, if you're going to the right, you have to put Tom on top of the line, otherwise he's going to just fall. You can't put him down here somewhere, right? So Tom obviously has to be on the line somewhere, and then he could walk in this direction. So if he is there, he's obviously going down a very steep hill. So we know this slope here is going to be negative. All right, so before I did anything else, I just already know my slope's negative. Now I know my b value is my y-intercept. So let's make this orange. Here's where I'm crossing the y-axis, okay, on this one. Okay, it's always an x value of 0 and a y value of 2. So that is your b value. They probably just want you to put 2. So maybe you could just write 2. That's probably what they want, because we're going to use that for the equation, I guess. All right, and then your slope is your rise over run, right? So we know it's going to be a fraction of some sort, okay? It's how much up or down does it go, and then how much left or right does it go. So that's my fraction line. This is just really bad to write it right here. Let's put it down here because this is where I have a little bit more room. Okay, so how much down do I have to go before I can hit another point? So you can look anywhere on your line and find a nice place where you can get a good point that doesn't have any decimals. So a nice point on your line. And the only one I see, if you go from the one you already have and you go down, it's right here where my mouse is, because this is a nice point on the grid. You can see it has lines there, and you want that really nice point. So I'm going to pick this point also. It can be any 2 points on the line, but now we have 2, an orange one and a blue one. And however much, obviously to go from orange to blue, because we can start wherever, but going from orange to blue, you have to go down to get there. So you go down 1, 2, 3, and now we don't go down anymore, but that's my rise. And then we go over to the left, 1. So there's 1, there's 3, there's 1. And so that is my m value, 3 over 1 or 3. And we said it was positive, so it is positive. So positive 3 is your m value. Now that you have both pieces of information, what's the equation? Y equals mx plus b. Y equals m, which is 3x, plus b, which is 2. And so you're just plugging in those two numbers in the equation. And I guess I should have made this one orange, since I like to use colors. All right, let's do the next one faster. What was my b value? Here I am. Actually, I'm not going to do this one. I showed you how to do one, but now you know it's a negative slope. So you do this one. Use the same strategy I just did, and you should be good to go. All right, guys, if you have any questions, see you in those office hours. Look forward to hanging out with you there. Adios.